All right, AP students, we are going to cover Chapter 17, focusing on human health and environmental risks. So Chapter 56 focuses on human disease. And what you should know is that there are different types of human diseases that we will talk about. Generally speaking, a disease is a way in which a human body or any other body is negatively impacted by a specific set of syndromes. An infectious disease is one that is going to be caused by a pathogen, and it can have an acute type of response, meaning that the symptoms are fast approaching and they are rapidly impacting the functioning skills of an organism. A chronic disease is one that is going to be long-term, and it will slowly impairs the functioning of an organism. There are different types of human diseases that we can focus on. The leading causes of death in the world are linked to cardiovascular health. Past that, or the next one in line, would be the presence of cancers and the infectious diseases, which are kind of grouped together, making almost 16% of the global deaths. Looking at the different risk factors that will affect people in different parts of the world differently, we can link certain types of diseases to how developed a country is, and if we have a low income or a higher income country that we have in mind. If you're dealing with a low income country, one of the top factors that will lead to chronic diseases are associated with the lack of safe drinking water. We have lack of food, nutritional food that's available to children, and that's oftentimes linked directly to poverty. In a high-income country, on the other hand, we have different sets of diseases that will affect and ultimately kill a population. The overeating and eating foods that are not very nutritional but very high in calories will lead to this cardiovascular disease that will impact those high-income population. If you think about the diet that we have kind of going on in North America, where we eat a lot of meat and a lot of processed foods, is going to be very different from a country that's maybe focusing more on fresh seafood that they eat and more vegetable based diet. In addition to poor diet in terms of that high calorie, high fat content, people in developed countries will also have a higher intake of alcohol, perhaps of drugs of different variety. They may have higher incidence of smoking, which is all going to link to a shorter lifespan. So when we look at this graph that will show the different risks around the world, in the high-income nations, the leading risks are associated with high blood pressure and tobacco use. We don't see that as much in a low-income nations because people can't afford those high-fat, processed foods, and then these the tobacco use that can be expensive. In a low-income nation, what people are facing is the lack of fresh water, right? They are looking at the childhood underweight that will lead to death or perhaps a lifelong health effects. Some infectious diseases that we are familiar with are historically important. They've had big impacts on global populations. And with COVID-19, we're kind of aware, and we know that those infectious diseases can have a huge impact on a global population. So obviously this PowerPoint was put together before COVID-19 happened. So COVID-19 is obviously not included in any of these slides, but now knowing that you guys have lived through this, you will be familiar, and some of those terms now become very familiar to us, which could not have been the case for students, let's say 5 years ago. So when we talk about epidemic, we're talking about a situation where a pathogen will cause a rapid increase in the number of people that have been affected by a disease. A pandemic is going to be an event where an epidemic occurs over a large geographic region, even worldwide. A plague is an infectious disease that's caused by a certain types of bacterium, and it was called by or carried by fleas. Malaria is still prevalent in developing countries. It's an infectious disease that's it's carried by mosquitoes, and that's where the use of DDT became very handy, because they were able to target mosquitoes in order to stop the spread of malaria. TB is a contagious disease that affects your lungs, and in the past, in different parts of the world, people have been vaccinated for TB, myself included. I have gotten my TB shot when I was a kid. So now when I need to go and get tested for TB, my tests always come back positive because I react to the TB test. So for me, I actually have to get a chest x-ray if I ever need to have a TB test because of the false positive, because of the fact that I was vaccinated. But in the United States, people do not vaccinate for TB because it's not as prevalent as it used to be in Europe in the past. So we have, in the last 20, 30 years or so, we had a number of infectious diseases that have emerged in different parts of the world. And now we're going to add the COVID-19 to the list. We've had a number of different illnesses that have become well known on the global scale, things that you will focus on later in the unit are going to be Zika virus. We will talk about SARS. We'll talk about Lyme's disease. All those terms I hope that sound familiar to you by now. And like I said, COVID-19 will definitely become part of this chart at some point. So talking about AIDS, AIDS is caused by the virus HIV, which affects your immune system. So generally speaking, HIV doesn't really kill people. It's the illnesses that your immune system is no longer able to fight that is going to ultimately kill the patient. Ebola is an infectious disease which has a very, very high death rate, and it's caused by the Ebola virus. And we are going to talk about how they actually figure out patient zero for Ebola and how that is still used. That type of method of contact tracing is currently used with the COVID-19 illness. Mad cow disease, it's a disease in which prions will mutate and they will affect a cow's nervous system. That was pretty well spread in England and in Europe. There were times where Cows were not being able to be shipped in and out or in between countries in Europe because of mad cow disease. Fun fact, myself in the United States, I will never be able to donate blood because of the fact that I've spent more than 5 years of my life in Europe. So they do worry that I might carry the mad cow disease prions, and they wouldn't know until there is a biopsy of my brain done. So there's your fun fact. Swine flu is a flu caused by the H1N1 virus, and the bird flu is a flu that's caused by a different variant of the H5N1 virus. SARS is the severe acute respiratory syndrome. It's a type of illness caused by coronavirus. West Nile virus, it's a virus that actually is it lives in hundreds of different species of birds, and it's transferred by mosquitoes. Lyme disease is spread or transmitted by ticks. A lot of times people will get freaked out when they see those larger ticks. Those are the dog ticks. They don't necessarily transmit Lyme disease. It's the deer ticks that we need to be aware of, and they are really, really tiny. So those are the ones that are carriers of Lyme disease. Zika virus has been well spread in Brazil and South and Central America, and then there were some cases in the United States where pregnant women are affected by this pathogen that causes the fetus to be born with a very small head and with brain damage. So, like I mentioned before, low-income countries will have different issues in terms of sanitation and lack of availability of clean drinking water, where high-income countries are going to be affected by the life choices that people make in terms of their diet, having exercise or lack thereof, use of alcohol and tobacco, etc. Looking at Module 57, we'll focus on toxicology and those chemical risks as we react as humans or any other animals might react to different types of chemicals. So there is a series of chemicals that cause major concern, and you should be familiar with those. Lead is oftentimes found in paint, in old paint, in gasoline, and then, like I mentioned, Flint, Michigan had a lead water issue when they switched the water source. Mercury comes from coal-burning power plants, and those two metals are neurotoxins, meaning that they will affect your nervous system. Arsenic is found in groundwater, and we've talked about the fact that it is found in the Midwest. In our area, it's fairly common. Asbestos. So people think about asbestos as this ultimately bad thing. However, asbestos is a terminology used for a mineral structure of different types of mineral, or a crystal structure for different types of minerals. And not all asbestos are bad. There are some that, yes, are bad, because what happens is if you have them in your building, so for example, if you live in an old home, or if you have an old school building or an old office building that's being remodeled, and they want to remove asbestos, you cannot have it be airborne, because then it gets into your lungs and it causes lung damage, eventually leading to lung cancer. So the way to do asbestos remediation is pretty much when they remove the surfaces. So for example, you have popcorn ceiling in your old house, and you're going to remove that popcorn ceiling, and you might find asbestos underneath it. What they would do is they pretty much seal up your entire house. They keep that ceiling wet because they don't want that asbestos to be airborne, to dry up and be airborne when they're scraping it off. So they keep it wet, and they remove it as a toxic waste from your home. So the biggest thing is you do not want asbestos to be airborne. If you have asbestos in your home and you live in this house and you don't disturb it, you don't do major remodeling, and you don't want to remove this popcorn ceiling, then you're fine. Asbestos is not going to affect you if it's left alone. Like I said, it becomes an issue where there's remodeling projects going on. Okay. Radon is another type of element that we find here in our area, and oftentimes you will have radon remediation systems in homes because they have detected radon gas in your home. So that can lead to lung cancer, and generally people will find out if they have radon in their home when they want to sell their house and they're doing their home inspection, and that's when they find that there's radon in their home. And part of the contingency in terms of selling the home is to install that radon remediation system. Okay, and then we have alcohol, and then the last one I did want to mention again is DDT. Like I said, that's one that you will need to be familiar with. It is a type of insecticide that's been banned since 1972, and it affects the entire food chain from the very basic organisms in, let's say, a pond or a lake, and it bioaccumulates in a food chain, so it remains in that population over time. Like I mentioned before, neurotoxins are ones that will disrupt the nervous system of animals. You have chemicals that may cause cancer, and then you can have chemicals that will make or cause damage to the genetic material within the cell. You might have certain chemicals that will interfere with the development of embryos or fetuses, and like I said, Zika virus is one that will affect unborn babies. You have some allergens that will cause allergic reaction, and then endocrine disruptors are going to be one that interfere with the hormone balance in your body. So how do we know what's bad and how much of something is actually bad? Well, we can have a number of ways to determine how harmful a chemical is through a series of studies. We can have a dose-response study, a prospective, and a retrospective type of study. A dose-response study is going to be one that will expose organisms to different amounts of chemical and then collect observations in terms of what are the responses, including how many deaths we've had, or how many individuals have been, their reproductive system has been affected, or their behavior has changed dramatically based on whatever exposure is. An acute study is going to be an experiment that will look at organisms in that have been exposed to an environmental hazard for a short duration, but it's going to be quick. That's one of the labs that you are going to be working on, is an acute study with nicotine exposure to certain organisms that we have. A chronic study is going to be one that will look at the organisms that have been exposed to this chemical or an environmental hazard for a long period of time. An LD50 study is one, again, that you are going to be doing, is observing what a lethal dose is for a chemical that will lead to 50% of that population that has been exposed to that chemical to die. So again, LD50 is going to be the lethal dose of 50% of the individuals exposed. We can have this study of a hypothetical unit of a chemical that's being administered to a certain population of organisms, and the LD50 value would be the dose that caused 50% of our population to die as a result of that chemical. We can have different types of dose response studies that we can complete. Sublethal effect is going to be one where the environmental hazard is not lethal, but it may actually affect the organism's behavior or reproduction cycle. The ED50, it is going to be different than LD50 study. Remember, LD50 study is going to be the lethal dose of 50%. ED50 is going to be a number of, or a dose that will have a 50% of that population experience a harmful effect. However, it is not lethal. Okay, it's just have a negative or a harmful effect on that population. A retrospective study is going to look almost in the past and see how people or organisms have been progressing or developing since they've been exposed to an environmental hazard in the past. Prospective study is going to be one that might, looking at people that might become exposed to environmental hazard sometime in the future. We can look at the different types of factors that will determine how the concentrations of chemicals are going to affect different organisms. And we can look at the route of exposure, meaning that let's analyze how the individual has come to contact with an environmental hazard, for example, certain types of chemicals. And there are different types of ways that we can be exposed to harmful chemicals, right? We can have air pollution. The food we might eat might be compromised in any way, right? There might be some soil pollution. Our fetuses or our babies can be affected by certain chemical that we can be exposed to. And of course, water pollution can lead to us being exposed to certain chemicals. Water pollution is also going to be a great vector for those waterborne diseases. Water is going to be a great factor because the chemicals solubility is going to tell us how greatly it is going to dissolve in water. So a chemical that's easily soluble in water, it can be washed off surfaces very easily. It can affect groundwater. It can, run off into waters like streams and rivers and lakes. And then, that can have a great impact on population, especially in areas that people use water straight from a river for drinking and cooking. Fat-soluble chemicals will generally not be very readily soluble in water, but are going to be found in higher concentrations in soils that will underlie the bodies of water. Bioaccumulation is a term that describes an increased concentration of a chemical within an organism over time. So somebody can be exposed to a certain chemical in the food that they eat, and that chemical just accumulates in their body because they keep consuming it. Biomagnification is a little different because biomagnification is actually the movement of chemical and the concentration of that chemical become greater and greater as we move up the food chain. And then we can look at persistence of chemicals or how long they remain in the environment over longer periods of time. So here we have bioaccumulation and biomagnification shown in a diagram here. So again, we're talking about DDT. The exposure, the initial exposure is going to be affecting those organisms in the lower trophic levels, such as the plankton here in the lake. That plankton will be consumed by other organisms and it will just move up in that food chain and eventually leading to a higher concentration of that DDT in the higher you move in a food chain. Here we have a table showing us the time frames for persistence in different chemicals in the environment. You guys can kind of look through this. The important thing is to realize is that DDT stays in the environment for a really long time. We're talking about 30 years in the soil once it's applied. We can look at the different risk analysis methods and see at what point can we kind of figure it out, what is the balance between potential harm and against other factors, like what is the benefit to risk analysis here. So environmental hazard can be defined pretty much anything in the environment that can potentially cause harm to any organisms. It doesn't always have to be just related to humans. And we can look at the risk analysis starting with risk assessment. So we want to identify, the hazard itself, determine what is the acceptable level of risk that we are willing to take, and then how do we determine the policy and laws to, prevent any major issues from happening. For example, here we can look at the risk assessment for your probability of death in the United States. And 1 out of 7 people in the United States are most likely going to die from an illness related to heart disease and or cancer. You have a pretty good chance of not getting hit by a lightning and dying from that, right? 1 person out of 160, almost 2,000 people are going to die by lightning. So, it's very different than looking at the heart disease, right? Are we supposed to be writing a lot of laws and spending a lot of times putting policies together for protection from lightning? Probably not as much as we should focus on heart disease and cancer research. We can look at the risk assessments in 2 different ways, in a qualitative or a quantitative way. A qualitative assessment will not include any data. In a quantitative risk assessment, we are focusing on a data-driven assessment. So like I said here, the risk is going to be determined by looking at the probability of you actually being exposed to that hazard, and then what are the chances of you being harmed if actually exposed to that particular hazard. And some people are willing to live with higher risk while others may not, right? And those that will be willing to say, okay, I am going to accept some risk, at what point some risk is too much, right? That you are not willing to take that anymore. We can have 2 different standards of risks that can be kind of driven by two different types of philosophies. The first one is considered innocent until proven guilty. The other one is the precautionary principle. And we can see the difference between these two, where we, in the first scenario here, in the innocent until proven guilty principle, we do introduce something that will require the researchers to prove that let's say, chemical is harmful. So you are using that chemical until you are proven that it is not safe. In a precautionary principle, you're doing that testing and you want to make sure that your chemical is safe before you actually allowing it to hit the market. And there are two agreements as it relates to hazardous chemicals, the Stockholm Convention and the REACH agreement from 2007. The Stockholm Convention, it actually had a number of nations that came into consensus to ban 12 chemicals out of the usage for humans. And then the 2007 agreement, the REACH agreement, talked about the regulation of use, transport of different types of chemicals. So this will conclude our notes for Chapter 17. Like I said, we are going to do a number of activities and looking at different diseases in more detail, and I will see you in class.